Alright, today we're going to pull back the curtain on one of JavaScript's most powerful and, let's be honest, most confusing features, prototypal inheritance. It's kind of like the secret sauce that makes JavaScript objects so incredibly flexible. And we're going to figure it all out by solving a very, very strange little mystery. So, to really get a grip on how prototypes work, we're going to play detective for a bit. We're going to investigate a pretty weird case. Think of it as a little puzzle that once we solve it is going to reveal a fundamental truth about how JavaScript really works under the hood. So here's the puzzle. Imagine you've got two hamsters. You give a nice, tasty apple to the first one. But then you go check on the second hamster and somehow it's also full. How in the world is that possible? This is the core question we're here to answer. Okay, let's look at the evidence. We have this base hamster object, right? And it has a property called stomach, which is just an empty array. Then we create two new hamsters, speedy and lazy, and we link them both back to this main hamster object. Seems simple enough, doesn't it? But what you're looking at right here, this is the scene of the crime. To solve this case, we've got to first understand this sort of hidden mechanism that connects pretty much all objects in JavaScript. It's this secret chain that tells the language exactly where to look for stuff. So here it is. Every single object in JavaScript is a hidden internal property. The official spec calls it prototype. Now this property points to another object, which we call its prototype. So when JavaScript can't find a property on an object you're asking about, it just automatically goes and looks at its prototype. That, right there, is the whole essence of prototypal inheritance. So how do we actually see this hidden link? Well, for a long time, we've used this special underscore underscore proto property. Now, yeah, there are more modern ways to do this, but underscore underscore proto is just a fantastic way to visualize what's actually going on. As you can see right there, we're explicitly setting the animal object to be the prototype for our rabbit object. And with just that one line of code, boom, we've created a link in the chain. And this shows you exactly how that chain works. It's brilliant. When we ask for rabbit.eats, JavaScript first checks the rabbit object itself. Is there an eats property there? Nope. Okay, no problem. So it just follows that underscore proto link right up to the animal object. Does animal have an eats property? Yes, it does. And that's the value it gives back. It's kind of like asking a friend for a tool. And if they don't have it, they automatically ask their neighbor for you. Okay, so we've got the chain down. But here comes the plot twist. And this part is absolutely critical for solving our hamster mystery. See, the prototype chain behaves completely differently depending on if you're reading a property or if you're writing to one. This slide lays it all out. When you read a property, like we just did with rabbit.eats, JavaScript will search all the way up that prototype chain until it finds what it's looking for. But, and this is a huge but, when you write or delete a property, that operation happens directly on the object itself. It does not go up and touch the prototype. You got to remember that. We're getting so close. We have just one more major clue to uncover before we can crack this case wide open. And it all comes down to one of the most famous, and maybe infamous, keywords in all of JavaScript, the this keyword. You should tattoo this rule on your brain. It does not matter if a method is on the object itself or 5 levels up the prototype chain. When you call a method, this is always the object that came right before the dot in the call. That's it. That is the one and only rule. Let's look at a quick example to make this crystal clear. Here, the full name setter method, it's defined on the user prototype. But when we call admin.fullname, what's the object before the dot? It's admin. So inside that method, this is referring to admin. Any properties it sets will be set directly on the admin object, not on its user prototype. All right, the investigation is complete. We've got all the clues. We know about the prototype chain, we get the difference between reading and writing, and we know exactly how this works. Let's go back to our hamsters and finally solve this thing. Let's trace the crime. When we call speedy.eat, a rule says this becomes speedy. Then the code tries to find this.stomach. It looks on speedy, but there's no stomach property there. So what does it do? It follows the prototype chain up to hamster and finds the stomach array. And then it pushes the food into that shared prototypal stomach. That's the problem. The read operation found the shared stomach and then it was modified. Both hamsters are sharing one single stomach. So the million-dollar question, how do we fix this? Well, it's actually surprisingly simple. We need to make sure that any property that describes the state of an object, like a stomach, belongs to that specific object directly. We can do that just by making sure each hamster gets its own empty stomach array right when it's created. And look at the result. Now, when speedy.eat gets called, JavaScript looks for stomach on speedy, and bam, it finds it immediately. It never even needs to look up the prototype chain. The shared stomach on the hamster prototype is completely ignored, and Speedy's own personal stomach gets the food. Mystery solved. So what have we actually learned from our little furry friends here? Let's just quickly recap the fundamental rules of prototypes that this whole case has taught us. Okay, here are the big takeaways. First, objects are linked by that hidden triple dash prototype property. Second, reading a property makes JavaScript search up that chain, but writing to a property happens directly on the object. Third, this is all about how you call the method, not where it's defined. And finally, the most important lesson of all. Methods, the things objects do, are perfect for sharing via prototypes. But state, the things objects have, should almost always belong to the object itself. And that leaves us with one final thought. In a language where pretty much everything is an object, this one single simple mechanism, the prototype chain, is what enables the entire system of inheritance and code reuse. It's like the invisible thread that ties the whole language together. So what else does it make possible? That's something to think about. I really hope this explainer was helpful, and thanks for joining me.